Okay, today we're going to start with 2.1, Algebra 2, and I just want to do a really quick review from topics that we started last chapter. So we're going to look at examples where we want to describe the transformation of f of x equals x squared. Chapter 2 is going to be all about the quadratics, all about the parabolas. So we want to describe the transformation of f of x equals x squared represented by g. So if g of x looks like this, I want you to keep in mind that what happens when there's a constant that's multiplied only to the x. It's not applied to the whole function, it's only applied to the x. Remember, those are horizontal scaling. So this would be a horizontal stretch by a factor of 3, because if this is a, the factor of scaling is 1 over a. And that's the biggest difference between a horizontal scaling and vertical. So now look at this case, you can see that the whole function is being multiplied by a constant. So this time we have a vertical stretch by a factor of 3, because this, if it's a vertical scaling, this and my factor of scaling is exactly the same. And then it's shifted 1 unit to the right. This one is g of x equals the opposite of the quantity x plus 3 squared plus 2. So first of all, I know that this represents a reflection in the x-axis. It's shifted 3 units to the left and then 2 units down. So hopefully that was all just a review for you. And we're going to talk about the vertex form of a quadratic equation, of a quadratic function. This happens to be my personal favorite form of the quadratic function because, well, I'll tell you in a minute. Actually, I'll tell you right now. Because all I have to do is look at this equation, look at this function, and I know where the vertex is, because the vertex is at hk. Okay, A indicates either a reflection in the x-axis, or it indicates a vertical stretch or shrink. H indicates a horizontal translation. Remember, a translation is just sliding it up or down, back and forth. And K indicates a vertical translation. So let's just look at an example. Let the graph of G be a vertical stretch by a factor of 2 and a reflection in the x-axis followed by a translation 3 units down of the graph of f of x equals x squared. Okay, well, that's a lot of information there. Let's just take it one little step at a time. So the first thing I'm going to do is represent a vertical stretch by a factor of 2. That's the first thing they told me up here. That means I'm going to take f and multiply it by 2. The next step is to reflect that in the x-axis. That means you just make this the opposite. So now we have negative 2x squared. And then the final step is shifting it 3 units down, hence the minus 3. So g of x equals the opposite of 2 times x squared minus 3. All right. So here's an I don't know if you guys remember the other day in class, I think it was Max asked me, why is it if let's say the function said x plus 2 squared, why is this a shift to the left and not a shift to the right? And remember when I said I'm going to explain that to you in the next chapter? I'm going to explain it right now. So let's look again at the formula of the vertex form of a quadratic equation, a quadratic function. So if the horizontal shift is positive 3, that's a move to the right, right? Then this part right here, x minus h, is going to equal x minus 3. So to make this maybe a little easier to understand, let's just set x minus h equal to x minus 3 and find out what h is. So if x minus h equals x minus 3, I know my x's are going to cancel. And now I have the opposite of h is negative 3. That means that h is positive 3. So if x is positive 3, that means that part of my function would be x minus whatever h is, which is 3. So this, because h is positive and it's a move to the right, but inside parentheses, it's going to say x minus 3. Hopefully that clears it up. And thanks for joining me.